Chapter 8, Section 9 is the last set of notes in Unit 8. And what this last section is going to do is it's going to tie in whether you know everything you should know with degrees, with radians, and then our very big key thing that is new for a lot of you is called solving. We're actually going to figure out which angles have certain ratios. It will be the way that you find correct angles for ratios, and we'll talk about that here in a second. So there's two ideas here. I divided your notes up into the top and the bottom. The top of your notes deals with what's positive and what's negative in which quadrants. So I wrote over here a little tiny graph that in quadrant 1, what's positive, the cosine, the sine, all of them are positive. The sine is positive in quadrant 2. The tangent is positive, and the cosine is positive in quadrant 4. And remember, the cousins also go with that. So tangent, cotangent are positive. Sine and cosecant are positive. All of them are positive here. And then cosine and secant is positive in quadrant 4 as well. And the way they disguise those questions is they're going to ask you, where is this greater than 0? If it says anything, if it says something's greater than 0, for example, if they're asking you where the tangent of theta is greater than 0, they're basically saying, where is the tangent positive? If they say something less than 0, they're saying, where is it negative? Which means, if you know this and how it ties into the 6 trig functions, you should know where things are negative and positive. The only other thing that I need to mention besides that is the word and. And in mathematical terms means both. It means what works for this and for that. Sometimes you're going to know that there are 2 places where the secant is less than 0, because there are. Some places, there are 2 different places where the cotangent is greater than 0. But the word and means which one works for both. Keep that in mind. Lastly, before we go into these examples, a negative or positive trig function squared. If we square it, it results in a positive ratio. We're going to use that a lot. Think about it. A negative times a negative is a positive. A positive times a positive is a positive. And so it doesn't matter if it's a negative ratio or trig function squared or a positive trig function squared. They both will end up being positive and only positive, never negative for that matter. Let's look at some examples. This says, identify the possible quadrant or quadrants in which the terminating ray for theta could lie. The tangent of theta greater than 0. Which quadrants could theta be in? And if you know, I would like for you to tell the person you're sitting next to what you think the quadrants are for number 3. Go.
Quadrants 3 and 1.
Yeah, 3 and 1 comes positive.
Show of hands. How many of you got quadrants 1 and 3? Raise your hand, please. Ooh, good. Exactly. Tangent is positive in quadrant 1. All of them are positive. Tangent is positive also in quadrant 3. All students take calculus. That's one way to do it. Or you could say, since the cosine is positive and the sine is positive, the positive divided by a positive is a positive. That's 1. And then a negative divided by a negative is a positive, is 3. This has a keyword and. And means both. So, where is the secant of an angle less than 0, and where is the cotangent greater than 0? I'm hoping you can figure that out with your partner before you answer me. What do you think the answer is? Discuss with your neighbor, please.
Quadrant 3. Because secant is opposite of sine, which is the x. Or no, it's the y. What?
Secant is the opposite of cosine.
Oh shoot! Gosh dang it. It's gonna kill me because. Oh, so it's y. Well, it'll still be the same.
Yeah.
Yeah, it'll still be the same. Lucky.
2 or 4, 1, 2 or 4.
If the secant of an angle is less than 0, then we're talking about where it's negative. Secant is the reciprocal to cosine. Cosine's negative here and here. We'll call this the red piece. The cotangent is greater than 0. Where is the cotangent positive? It's the same place where tangent is positive. Tangent is positive here, and tangent is positive here. So what works for both? Where is it true for both? If you look, they're both true here in this quadrant, so your correct answer should be quadrant 3. Show of hands, how many of you got quadrant 3? Good job. Hands down. If you did not get it, I hope that makes sense to you. The last example is one of those examples that a lot of people had issues with in the past. So, what quadrants would the cosine squared of theta be greater than 0? I want you to think about your answer, and I want you to discuss this with your partner. I will come back and then ask you how many of you have the correct answer in just a moment. Discuss with your neighbor what you think it is.
It's all quadrants.
All of them?
Because it says a negative or positive trig function squared results in positive ratio. So all of them.
Well, it has to be 1 or 4.
What?
1 or 4 for this one?
It's all of them.
Wow,
What?
oh, wait.
Anything squared in quadrants is possible.
I am just curious, how many of you said all 4 quadrants? Raise your hand. Good, you are correct. If you didn't get it, think of it like this. Even if you had an angle like 135 degrees, the cosine is negative there, right? Like a cosine, let me write this out. Cosine of 135 degrees is a negative root 2 over 2. Just because I know that, right? If you think about taking that cosine of an angle and then you squared it, what you end up having is a negative times a negative. What is a negative times a negative? It is that going to be greater than 0? So it doesn't matter whether you end up having a negative ratio for cosine or a positive. Any angle would work because a negative times a negative is a positive for cosine, and that means these quadrants are going to work, and it also means that the positive times a positive would still be greater than 0. All 4 quadrants would work. Any angle would have a positive result for that answer. Now, that doesn't mean that all your answers will be that way. if you think about it, what if I were to turn this to a less than symbol? Where would the cosine squared of theta be less than 0? Your answer would be? Nope, can't. It's always a positive result, so it can never be negative. If it was, you would say that it doesn't exist, no solution. That is a possible answer. So, the first minor idea that is on your test comes from these 3 questions. You got to know what's negative where. The major idea in this section that you all have to get really good at, I want to say there's 2 or 3 of these on your test, whereas up above there might be only 1 or 2, is do you know how to solve for theta? Can you figure out what angle gives you this ratio? So the first thing I need to say is this. If you're trying to solve for theta, you are trying to find an angle with a certain ratio. Usually there are 2 answers. And the reason why there's usually 2 answers is because there are 2 quadrants where the functions are positive and 2 quadrants where the functions are negative. Do not just look for one answer. If the sign is positive in quadrants 1 and 2, then you might have 2 possible answers if you're looking for a positive ratio in quadrant 1 and a positive ratio in quadrant 2. The cosine is positive in quadrants 1 and 4. There might be a quadrant 1 answer and a quadrant 4 answer. So I say that because most of the time you will have 2 answers for each ratio you are trying to find. But sometimes there'll be 1 answer. If we're talking about the top of the unit circle, there's only 1 place where the sine ratio is equal to 1. It's right here. Pi over 2 or 90 degrees. No other place on the unit circle has a sine ratio at the exact top of the unit circle. That only has 1 answer. Matter of fact, there's only 1 place where the sine is equal to a -1. Has 1 answer. If we're looking at sine ratios, there are 2 answers other places. There's 1 here, 1 there. There's 1 here, 1 there. If you're looking at cosine ratios, there are 2 answers everywhere. There's 2 places where cosine is equal to 0. But sometimes if you get to the edge, there's only 1 place where the cosine is equal to 1 or -1. Sometimes there's no answer if there's a ratio that doesn't exist on the unit circle as well. So I say that most of the time there's 2 answers because sometimes there's 1 answer and sometimes there are no answers that work. Remember how we talked about cosine squared being less than 0? There'd be no solution for that. There's no answers that work, just so you know. Before I move on, I need to make sure that you understand this because it's a major concept. Why, we're going to have North person start the conversation. Why are there sometimes 2 answers for solving for theta? South person, why are there sometimes 0 solutions and why are there sometimes 1 solution when you're solving for theta? I would love for you to have that conversation with your partner. Discuss, please.
On a unit circle, and depending whether they're positive or negative, that's how you can find out where the segments are.
Sometimes there's 0. So let's say it's on, let's say it's exactly on 100 degrees, but it's like trying to find y actually 0. or there's like one, let's say it's like exactly 90 degrees, and it's you're like wide
Now, just to be clear, not every single time will you only have one answer or two answers or zero answers. Sometimes you might have three answers, and sometimes you might have four. It just depends on how the question is set up. We'll discuss how to do that in these examples down here for 12 and 17. You'll see what I mean. What we're going to do is we're going to follow these four steps. If you don't know what to do, go back to these four steps, read them. They are going to guide you as you do every single problem. If I follow these four steps, I can do every single problem in your homework. We're going to isolate the trig function. Get everything else to the other side of the equal sign. We're going to square root anything squared. Not all the time, because not everything's squared, but sometimes it is. It's the same thing as the absolute value. What does that mean? That means this. If you are solving for something squared, let's do something very simple. X squared equals 4. If you square root something squared, it is not just a positive possibility. X could be not just 2, 2 times 2 is 4, but it could also be negative 2, because negative 2 times negative 2 is 4. So anytime you're square rooting anything, there are two possibilities for this, which is why you're going to see me do this on my work. I will turn the square root of x squared into the absolute value of x, so that you remember there's two possibilities, a positive distance from 0 and a negative distance from 0. If you square root something squared, it has a positive possibility and a negative possibility. I do not care if you show me this absolute value step. You can, if you want to do it. Every person in this school who teaches math will put a little smiley face because all right, I love that. Okay, we love it. Why is this going to be different? Because sometimes you're going to have sine squared of theta equals 4. And you might have to square root. And when you square root even a trig function squared, there's two possibilities for that. And we'll end up going into something that looks like that. And I probably should have done 1. And then there'd be a positive 1 possibility and a negative 1 possibility. Just so you're aware. That's what that means. We're going to find places on the unit circle that has the given ratio. Every single thing you do should be on the unit circle. If you are getting something that's not on the unit circle in this section, then you have done something wrong. Just so you know, every problem should be on the unit circle. There's 2 answers per ratios in the quadrants. There's 2 or 1 answer per quadrantal. If there is something that ends up on the axis out here, at the 1, 0, at the 0, 1, or the negative 1, 0, or the 0, negative 1, it might have 1 answer or it might have 2, depending if it's the sine or the cosine, or the secant or cosecant, for that matter. Just so you know. You may have to set the equation to 0, and you may have to use the zero product property in Chapter 1, Section 7 that we've already learned it to solve. So with that being said, let's do some examples following these 4 steps. This is number 12. It says, solve for all values of theta such that 0 degrees is less than or equal to theta and less than 360 degrees. Period. Give all answers in degrees. If you ever see a test question that looks like this, it's telling you your angle is between 0 and 360. It could be equal to 0, but it has to be smaller than 360. You would never give 0 and 360 as an answer because it's not equal to the 360. There is a line missing there on purpose. We want 0, but we don't want 360. It's just going once around the circle, not coterminal at 0. Okay? And notice it says give answer in degrees. If you give my answer in radians when it says degrees, -1 on a test. If it says give all answers in radians on a test and you give it in degrees, it's -1 on the test. I will grade you based off of how it is asked on your quiz or test. Let's do this example. Step number 1 says isolate the trig function. This trig function is 2 cosine theta. It has a +1 next to it. I would get rid of the 1 first by subtracting 1 to the other side. That would make 2 cosine theta equals -1. Always get rid of addition and subtraction first. And since the 2 is multiplying the trig function, do the opposite of multiply by 2 and divide by 2. So that you have cosine of theta is equal to -1/2. That's step 1. There is nothing squared here. I don't have to do step 2. Step 3, find the place on the unit circle that has the given ratio. If the cosine of an angle is -1/2, you should already be thinking, where is cosine negative? Which quadrants? Good. I'm going to put C negative there, just so that you know in quadrants 2 it's negative, and quadrants 3 is negative. And so I'm already thinking like here and here. I need a degree angle that has a cosine that has a -1/2. So I have to think in terms of degrees, and I have to think of a cosine that's on the unit circle. So of course I'm going to use the hand trick, right? That doesn't have a cosine of 1/2. That has a cosine of 3/2. That has a cosine of √2/2. This has a cosine of 1/2, right? I have to know what this angle is in degrees. This is how many degrees? 60. That's this quadrant 1. Let me put a little dotted line, like dotted. This is not the one I'm using. But in my head, I have to know 60 degrees. But the quadrant 2 answer and the quadrant 3 answer is going to use 60 degrees. It's 60 degrees to the x-axis and from the x-axis. Do you know what your 2 answers are already? You have 2 solutions. They are 120 degrees and Mr. Prama will always give his answers in something called a solution set. That's this fancy bracketed thing called the braces. I know that's a weird term, but that's what they are called. They're called curly brackets or braces. If you actually go to Wikipedia, that's what it's called. I put my solutions from least to greatest. Not that it has to be, but I would prefer you do that as well. Let's have the south person. South person, I got 2 answers, 120 degrees and 240 degrees. South person, would you explain what did we do first and second and third, and why did I get 60 degrees but now I have 120 and 240? How did I get that as my final answer? South person, do your best to explain it to the north person, please. Discuss.
Isolated the trig function is 2 cosine theta. You divide it by 2. Divided 2 by everything. And then just cosine theta is equal to negative 1 half. And then you find negative 1 half in the circle. And there's 2 spots where it can be. The cosine is the x. Why couldn't it be negative 120, negative 240? Or do the brackets say that?
Well, let me point to something. Look at.
Oh, okay, so will there be somewhere like between 0 and negative 260?
If you were in a trig class, I could say, hey, find me an angle between negative 360 and 0 degrees. Then those answers would be valid. But not if I say between 0 and 360. I only want positive angles between one that's within the first revolution. So that brings us to the next type of question, our next example. I'm hoping that makes sense to you. How does it get harder? It gets harder when there's multiple answers. We had 2 solutions there. Doesn't mean that we always have 2 solutions. Sometimes it's more. Number 17. Solve for all values of theta such that we are now in radians. Our answer should be somewhere between 0 and 2 pi. It can be equal to 0, but not equal to 2 pi. 4 sine squared minus 1 equals theta. The first thing I do is still isolate this. I want this by itself. Get rid of addition and subtraction first. Add the 1. Four is multiplying sine squared, divide by 4. Now we have something different. We have sine squared of theta is equal to 1/4. This is where step 2 comes into play. Square root anything that is squared. The opposite of squaring something is rooting it. Whatever you do to one side, you do to the other. Thank you. When you square root something squared, that is the same thing as the absolute value. That's how I usually will write it in my work. You don't have to do that if you don't want to. If you do, that's totally fine. The square root of 1/4 is the same thing as the square root of 1 over the square root of 4. I know what that is. That's 1/2.
Wait, is that just sine?
Sine of theta. The square and the square root basically cancel each other out, but it's this absolute value. So this is equal to a positive ratio and or a negative ratio. There's the positive possibility and the negative one. I'm going to write it like this, plus or minus 1/2. Which means the sine of theta could be a positive 1/2 or the sine of theta could be equal to a negative 1/2. There are 2 places where the sine's positive. There are 2 places where the sign is negative. We need to find all the solutions between 0 and 2 pi for our answer. We need a sine ratio that's 1/2. Nope. Cosine's on the left, sine is on the right. What is this in radians? In radians. Say it if you know it. Say it out loud.
Pi over 6.
Pi over 6. That is the reference angle. That's actually this possibility right there. Now the good news is that all the denominators will be the same. So if you go over here to the quadrant 2 possibility, in your mind, I literally just go over here to this pi, and I say 6 pi over 6. Just change it to that denominator. That's the same thing as pi. which means it's how much less than or how much more than. And then in your head, you do the math, and this one is 5 pi over 6, and this one is, look how fast that is. And this, if this is 12 pi over 6, because that's 2 pi, then that's short by pi over 6. This is 11 pi over 6. So you have 4 solutions. Your 4 solutions are from least to greatest in a solution set bracket. There's my answer. Miss Almedo.
On the test, would we get dock points if we don't put them in the brackets?
No. I would not dock you. I prefer it this way. It's the correct mathematical way to write your answer. What you're telling me is the solution is this, or this, or this, or this, or all of them. North person, it's your turn. I got 4 answers. I need the north person to explain to the south person, how did Mr. Promo get all 4 answers? Walk them through the start of the problem, how come I have a positive, negative, and so on. Discuss with your partner, please.
Switch the one over to the other side to make it easier. Then we need to get theta, sine theta by itself. So we're going to take 4 and put it in the other side of it. So we got sine squared theta equals 1/4. But to get rid of the square, you have to root it. So if you root sine theta and then you root 1/4, you get the square root of 1 over the square root of 4. And the square root of 4 is 2. So the absolute value of sine theta equals 1/2, and then you go to all the 1/2 signs, and then take it.
So because you square rooted it, that's why you had to find one positive and negative.
Because it was something squared.
Oh, okay, so negative 1/2.
If it was just sine theta equals 1/4, we'd be looking for the 1/4. But then we would have done something wrong because there is no 1/4 on the unit circle. Last example is number 21. Number 21 is different than all your other ones because it uses something from chapter 1, section 7 that you're supposed to be applying to this question. Not foil. You could foil, but really you don't need to. That would be extra work that you don't need to do. Since this times this is equal to 0, we can go directly into the zero product property, which says if A times B is equal to 0, then either A is 0 or B is 0, or they both are equal to 0. Which means, since this is a product, I can then write that the tangent of theta plus root 3 is equal to 0, or the tangent of theta minus 1 is equal to 0. We have 2 possible branches, if you will. You may have some solutions here. You may have some solutions there. There might be 2 solutions for this branch and 2 solutions for this branch. I don't know. Just depends. If I was working this question out, I'd subtract root 3. Becomes negative root 3. If I were to add 1, be tangent of theta equals 1. And so really, we're looking for where is the tangent equal to a negative. I should be thinking of 2 quadrants. I should be thinking, where's the tangent positive? Thinking these two quadrants. Make sure that you can tell this is a -3. It doesn't, it almost looks like it's not part of it. So let me put it like this, -√3. That way you can really tell. And so I'm looking for an angle, and remember we're still in radians. I'm looking for a √3. That is on your unit circle whether you know it or not. If you fold this finger down, a sine divided by cosine would be 1 over √3. That's not the same thing. This is a √2 divided by √2. That simplifies to 1, by the way. Nope. What about this one? √3 divided by 1. Is that the same thing? Yes. My reference angle is
60.
Or in radians, pi over
3.
pi over 3. So I'm going to put a little dot right here and say it's pi over 3. So I need the quadrant 2 answer, which is what? Same reference angle. Pi over 3 on the inside. This is 3 pi over 3. So it's 2 pi over 3. And the quadrant 4 possibility. You're almost at 2 pi. You're almost at 6 pi over 3. These are our two solutions for the tangent of theta is equal to a -√3. Now we got to go over here to find two other angles that have a tangent ratio of a sine divided by cosine is equal to 1. Pi over 4. That's your quadrant 1 possibility. Add that to whatever pi is. I'm hoping you know it's 5 pi over 4. And then what you do is you write your answers in order from smallest to largest. And I will always put them in a solution set bracket. It's a long set of notes. It puts everything you know together into one lesson. I'm hoping it all makes sense to you. You will get a chance to work on these with your neighbor. If this video was helpful for you, my third period always reminds me, don't forget to like, subscribe, or leave your comments below.